We have another example on the board. We have 158,000. We have to convert this to binary. The highest weight which I can subtract from this number is 125,000. I have 125,000. 8 minus 5 is 3. 5 minus 2 is 3, and I have 0.0. The highest weight which I can subtract from this value is this one, and I have over here 0.03125. Subtract, we have 0, 0, 10, 9, this one is going to be 2. 10 minus 5 is 5, 9 minus 2 is 7, 2 minus 1 is 1, 3 minus 3 is 0, 0, 0. I'm going to stop at 5th bit after the binary point. It means that my answer is not going to be exactly 158,000. It's going to be approximately. If you want to make the answer closer to the given number, you're supposed to just keep going with another ways. But we are going to keep just 5 binary place values after the binary point. That's why my answer is going to be 0.000. Okay, let me write this answer one more time. I have 0.00101, and this is approximately in binary 158,000. This time we're supposed to convert 523,000 to binary. The highest weight which I can subtract from it is 0.5. Subtract. We have 3, 2, 0.0. Please notice that the value which we have obtained is lower than the lowest weight on the board. We said that we want to keep the answer with 5 bits after binary point. So I'm not going to perform subtraction anymore because I want to keep just 5 bits. So I'm going to simply write 0, binary point 1, and I have 0, 0, 0, 0. Okay, so I'm going to have my answer 0.1000 base 2. This binary number is equivalent to decimal 0.5. If you want to get the value closer to this one, you're supposed to extend your binary number by adding extra weights. But we are going to keep just 5 bits after the binary point. That's why this is the solution to my problem. This time we're supposed to convert 875,000 to binary. The highest weight which you can subtract from this number is 0.5 minus. And I'm going to have simply 5, 7, 3, and 0 over here. Next, from this number I can subtract 0.25. So I have 0.25. Subtract, and I'm going to have 5, 2, 1, 0. From this number I can subtract this one. I have 0.125, and I have 0. Anytime you end up with 0, you're supposed to stop performing your subtraction. So my binary point 0, and I want to keep 5 bits after the binary point. That's why I'm going to fill up the empty spaces by zeros. and my answer is 0.11100, of course, binary. So this is the solution to my problem.